Bismillahirrahmanirrahim. Our today's lab is to classify an image. We will basically learn the image classification. Now, first of all, we will see that what is basically an image classification, what are different types of image classification. Then we will perform supervised classification. We will see what steps they are involved in performing the supervised classification, and then we will finally conclude our lab, right? So the first thing, that what is basically an image classification. As we all know that as the satellite data, it became common, and a user can go to different website like Earth Explorer, and he can download different images of different spatial resolution, Landsat data, or other options which are available there. So once you have a satellite image, it comprised of different bands. Now we have learned in our intro to RS or basic remote sensing course that how to stack imagery. Once we have stacked the imagery, then we will perform image classification on that stacked imagery, right? So image classification is very simple, that if you group the pixels and assign each group a specific name, assign each group a specific class, so that is your image classification. For example, I have a satellite image, and the values that are digital number values or DN values which are recorded, they range from 0 to 255. Now I will make different classes. For example, I will make that from 0 to 50 there will be water class, 50 to 100 there will be vegetation class, 100 to 150 there will be some other class. So this is basically a mechanism through which we classify an image. Now image classification is simply defined as sorting of pixels into finite number of individual classes or categories of data based on their data file values, right? So if a pixel satisfies a certain set of criteria, then that pixel is assigned to the class, right? So it is basically there are two types. One is supervised classification and other one is unsupervised classification. Now what is the difference between them? Now if we have in an image DN values from 0 to 50, right, and we want to classify them as water, right? So one method is to take signature, is to take samples of water. For example, I take a sample of water that has a DN value of between 0 and 10, and then I take another water sample that has a value between 0 and 20, then I take another one that has value between 10 and 30. So these three samples, they are basically supervised or trained by the user, right? So this type of classification in which a user takes samples, that is termed as supervised classification. And the other method that is simple to classifying a data, statistical data, that you define some intervals, right? For example, from 0 to 50 class number 1, 50 to 100 class 2, 100 to 150 class 3, 150 to 200 class 4, and then later on after the result you see that 0 to 50 which class is in majority, and you assign that okay, this class belongs to water. So this is unsupervised classification. And the third type of classification is object based classification, which we will be learning in further labs, right? So this is a basic introduction of classification. Now we will perform this classification by using this methodology. We will open the Erdas image, we will input our study area image, then we will use signature editor, then we will be taking appropriate signatures, and then we will be performing supervised classification, and at the end we will have a classified image, right? And then we can evaluate this classified image in ArcMap. So this will be our methodology for today. As a first step, what you have to do is to start Erdas Imagine, browse to the folder where Erdas is installed. I have this one, you have to click this. Once you click this, a window will be opened, right? The next step is to add your data. I will open my data, open raster layer. For example, my data is study area image. So in this lab, I will be using a high resolution satellite image, and I will be performing my classification on a high resolution satellite image. You can click fit layer to window, right? Okay, once you click fit layer to window, this image is displayed here. You can change the band combinations from three. I have changed it to 3 to 1. You can change it of your choice, right, in which the area is visible. Now once your image has been incorporated in Erdas environment, there is no pre-processing need, so we will be moving on towards classification, right? So in that step, what we have to do is to take the signature editor, and we will be taking signatures, right? If you want to perform unsupervised classification, that is very easy. You just have to go to raster tab, you have to click on unsupervised, right? You have to input our study area image, you have to output your study area image. For example, I will name it as unsupervised image. You have to click OK and specify the number of classes, and you can assign the algorithm. One is k-mean and the second one is isodata. You may have covered what k-means does and what isodata does, right? These are two algorithms to calculate your classes. For example, I have 36 classes over here, and I just for the time being use these default values and click OK. So my image will be unsupervised classification will be executed, right? This is a simple mechanism to calculate to perform unsupervised classification. Now we are interested in today's lab is to perform supervised classification, right? So in order to perform supervised classification, we will be taking signatures or samples, and then we will classify our image based on those samples. Okay, once we have performed unsupervised classification, we can view the classification result from recent. So this is my unsupervised classification, right? So there are 36 classes, they are defined here. We can change the color, but in today's lab we will be focusing more on supervised classification, right? And we will be understanding that. So I will remove this. Now we have our study area image open. Now the next step what we have to do is we have to go to the raster, right? And in the raster we will select supervise, and then we will select the signature editor, right? So in this Erdas section, go to raster. In raster we will select supervise, and in supervise we will select signature editor, right? So we will be clicking the signature editor. Now what is signature editor? Signature editor is basically a tool which allows you to take signatures or samples of any feature, right? So this is the interface of signature editor window. Now what we have to do is to take samples, right, of different classes. Now we have to go to the drawing tab and draw a polygon, right? We have to, here we have this. Now go to the drawing tab. Here you can see the drawing tab with multispectral. Just click on the drawing tab. Okay, once you click on the drawing tab, there will be an option to draw the polygon. I will select this option. Now the first sample I want to select is of buildings. So you will zoom to the building and select a sample. Now the best method to take a sample is to avoid mixing. Sample should be pure, right? I will take another sample, right? Now I will be taking another one from different location. Let's take another one from different location. Now these are our houses, right? So we can, right? Now once you selected this sample, you can just zoom out and press shift and select all the samples which you have just created, right? By pressing shift you will open the signature editor. Once the samples are selected, you will open the signature editor, and I have to wait for a minute. so that this window is visualized. Okay, this is our signature editor, right? It has different option: file, save as, and it have edit option, evaluate option, feature creation option. Now what we have to do is to create samples or signatures, and then use this button to add these signature, and we will be using this button for signature merging, right? So these two buttons must be kept in mind: this one to add and this one to merge, right? That will be used in the next. Okay, once we press the shift button, we selected all the samples we for a residential area we have selected, and we clicked on this button to add this, right? Now the next step is to merge these four into single, right? So we will be using this to merge, and now we will delete this selection. Now I will rename it as residential, RESEDN, residential unit. Now in this way what you have to do is to take various samples of water, of vegetation, of parking lots, of buildings, and of other features, right? So 3 to 4 samples we will be taking for each, and then we will use this plus sign to add in individually of each, merge these 3 to 4 samples into one, rename it as residential unit, water, or so other. So this process is going to complete, and then we will be moving on, right? Now go to the drawing toolbar again, and for example I have this sample of road, right? So I will be selecting a road sample over here. Now I will be taking a road sample of over here. I have taken two. Now I can take this one as well, a road sample of over here, right? A road sample over here. Now let's take some other road samples. Okay, a road sample over here. So this is also a road, but it has spectral response different to the other road. So we have selected these sample. Now we will be pressing the shift button and selecting all these sample one by one. So I have here 1, 2, 3, and 5 samples. Now I will be opening this and click on this add button. These 5 samples will be added. I will select them, I will merge them, and delete this option and rename it as roads. Now you have to repeat this process by yourself, and you have to include as many classes as you want, and you have to take samples and try to incorporate as many classes as you like, right? Once we have our signatures ready, then we will move on towards classification. Okay, once we take enough signatures, like you can see in the screen, that I have took signature of barren land, industry units, shadow, water, marshy areas, parking lots, football ground, high-rise building, shopping plaza, and you can see that I have taken multiple signatures of each feature, right? Okay, once we have the signature file created, we will click on file, we will click on save as, and we will save this signature file into our directory wherever we want to save it. We will rename it as our signature file, and we will save it. Once this signature file is saved, the next step what we have to do is we have to go to raster, and we have to click the supervised tab. In supervised tab we will click supervised classification. Now here we will input our study area, and we will input our signature file which we have created just now, right? So I will browse to my image, and I will browse to recent and see where my signature file is. Here it is. Now I will output my classified image, into my folder where I want to save it. For example, let's name it as supervised image. Once we are done with this, we will click it OK. Now here we have different rules, right? If you can see that here parallel piped and feature space, these are two different rules, and we have five different types of algorithm. One is maximum likelihood, minimum distance, spectral angle mapper, and other. So these are different algorithms which need a separate section to explain each of them individually, that how it operates. Once all of this process is completed, we will click OK. Now our supervised image classification has begun, and in the meantime we will see that what output this classified image shows us. Okay, the process has been completed. Now I will open my raster layer. I will browse to recent, and here it is supervised image. I will click this supervised image. Now here I will remove the extra layers now, and will just focus on this image, supervised image. So here you can see that my buildings, they are classified, water bodies, marshy areas, all of these are classified. If you right click and click on display attribute table, you will have all of these classes here, and you can change the color combination as well. Now till here we are done with image classification. We have learned how to perform image classification, and what is the difference between supervised and unsupervised classification, and what output as a result you get after classifying your image. Okay, we finally conclude that when we performed supervised classification on a high resolution data set, although that classification is very good, accurate, visually it is appealing, but there are a lot of spectrally similar classes, right, which are mixed. For example, you can see that buildings, they are mixed with shadows. Similarly, you can see that roads, they are mixed with vegetation. So we conclude that this type supervised classification, when it is performed on a high resolution data, it produces non-homogeneous classes due to internal class spectral variability, because of the reason that our data was high resolution data, right? So it is more preferable, if you have a high resolution data set, you must go for object based classification instead of supervised or unsupervised classification. In case of low resolution data, the results, they are to some extent good than high resolution data set. Okay, once we have performed our classification and we have seen that what is the effect of performing the classification on a high resolution data set, now let's use a visualization tool. I have opened this classified imagery, and beneath that imagery is my study area image, right, which we use to classify. Now here you can see that we have a swipe tool. Now this tool is used to compare two images, right, at the same time. So you can see that this tool is visually comparing the two images, right? Now if I just stop this animation, and I can move on by holding this window, now you can see that shadows, they are in yellow colors. These are the building tops, they are correctly classified. So there is a very good classification that as a result we have got. But still you can see that here we have a barren land, that is, and vegetation, these two classes are mixing. And here similarly in road, some other barren land, that is mixing a lot. So it is good, but to improve it and to achieve an accuracy more than 95%, so we must go for object based classification, right? So that's all for today's lab. Thank you.